Hello everyone, welcome to another episode of Deep Dive Knowledge Talk. Hello, I've read the summary of the report on blockchain technology and its use cases. It seems quite comprehensive. Could you please explain to me what exactly is blockchain and how it works?
Certainly. Blockchain is a special kind of technology that acts as a digital ledger. It is made up of a series of blocks that store information and transactions. These blocks are securely linked together using cryptography, which means they are protected by advanced mathematical algorithms. Think of a blockchain as a chain of blocks, where each block contains a list of transactions. Just like in a real chain, each block is connected to the previous one. This connection makes it very difficult for anyone to tamper with the information stored in the blocks. Here's a simple analogy to help you understand how it works. Imagine a group of friends playing a game of Pass the Message. Each friend adds a new message to the previous one and passes it to the next friend. The chain keeps growing as more messages are added. In a blockchain, each block represents one of these messages, and the entire chain represents the complete history of all the messages. The difference is that instead of friends passing messages, it's computers on a network that validate and store each transaction. To ensure the security and immutability of the blockchain, each block contains a unique code called a cryptographic hash. This hash is like a digital fingerprint that verifies the integrity of the block. If someone tries to change any information in a block, the hash will change, and the change will be easily detected. Overall, blockchain technology allows multiple participants to have a shared and decentralized database where transactions can be securely recorded and verified without the need for a central authority.
Thank you for the clear explanation. I understand that blockchain technology uses cryptography to secure blocks of information and transactions, but I'm curious about the different types of blockchains mentioned in the summary. Could you elaborate on the differences between private, public, permissioned, and sidechains?
Sure. Let's start with private blockchains. A private blockchain is like a website owned by a company that is only accessible to its employees. It is not decentralized and is hosted on a secure organization database. Only authorized individuals with the passcode can make transactions, authenticate, or validate any changes in the blockchain. Examples of private blockchains are Hyperledger and Ripple. On the other hand, a public blockchain is open to everyone. It is like a public park where anyone can come and participate. It is decentralized and allows anyone to join and contribute to the activities happening on the blockchain. Bitcoin and Ethereum are examples of public blockchains. Now, let's talk about permissioned blockchains. Permissioned blockchains are a combination of private and public blockchains. They have elements of both and can be accessed by anyone if given permission by the administrators. Think of it like a Wi-Fi network that is available to a specific group of people. You can only access it if you have the ID or password. Permissioned blockchains are also known as hybrid blockchains or consortiums. Lastly, sidechains are like subordinate chains running parallel to the main blockchain. They allow users to send digital assets between different blockchains. It's like having a separate road alongside the main road for specific types of vehicles. Sidechains provide interoperability between different blockchains and enable the transfer of assets or data between them. I hope this explanation clarifies the differences between private, public, permissioned, and sidechains for you.
Thank you for the detailed explanation. It's much clearer now. I'm also interested in understanding the concepts of proof of work and proof of stake that were mentioned in the summary. Could you explain how these concepts relate to blockchain technology and how they contribute to its functionality?
Proof of work, POW, and proof of stake, POS, are two consensus mechanisms used in blockchain technology to validate transactions and maintain the integrity and security of the blockchain. Proof of work requires users to solve complex mathematical problems or algorithms in order to validate transactions and add them to the blockchain. This process is resource-intensive and requires a significant amount of computational power. Miners compete with each other to solve these puzzles, and the first one to find the correct solution is rewarded with new cryptocurrency coins as an incentive. This process ensures that transactions are verified and added to the blockchain in a fair and secure manner. On the other hand, proof of stake requires users to demonstrate ownership of a certain amount of cryptocurrency, their stake, in order to have the ability to validate additional blocks in the blockchain. Instead of solving complex mathematical problems, users are chosen to validate transactions based on the amount of cryptocurrency they hold and are willing to stake. In this case, the chances of being chosen to validate a block are proportional to the amount of cryptocurrency held by the user. This mechanism eliminates the need for resource-intensive mining and reduces energy consumption. Both POW and POS contribute to the functionality of blockchain technology by ensuring the security and immutability of the blockchain. POW provides a robust and proven method of validation, as the computational power required to override the blockchain's history is practically infeasible. POS, on the other hand, offers a more energy-efficient alternative that allows users to participate in block validation based on their stake in the cryptocurrency. The choice between POW and POS depends on various factors, including the goals of the blockchain network, energy efficiency considerations, and the level of security required. Some blockchains, like Bitcoin, currently use POW, while others, like Ethereum, are transitioning from POW to POS to improve scalability and reduce energy consumption.
Thank you for the detailed explanation of proof of work and proof of stake. It's interesting to see how these consensus mechanisms contribute to the security and energy efficiency of blockchain technology. Moving on, the summary mentioned the significance of blockchain technology, including clear and safe data, fast business deals, resistance to errors, and cost-effectiveness. Could you provide some examples or use cases that demonstrate how blockchain can revolutionize sectors such as cross-border payments and trade finance?
Sure. Let me provide you with a couple of examples to illustrate how blockchain technology can revolutionize sectors like cross-border payments and trade finance. 1. Cross-border payments and remittances. Traditionally, when you send money internationally, it goes through multiple banks and intermediaries, which can be slow and expensive. With blockchain, a network can be established involving financial institutions, remittance service providers, central and international banks. This network ensures secure and regulated participation. Now, imagine you want to send money to a friend in another country. Instead of going through multiple intermediaries, the blockchain network enables direct and instantaneous transactions. These transactions are recorded in a transparent and immutable ledger, ensuring transparency and security. Additionally, the fees for these transactions are significantly lower compared to traditional methods. 2. Trade finance. In the field of trade finance, blockchain can streamline and secure the various processes involved in international trade. A private and permissioned blockchain network can connect importers, exporters, banks, and trade finance firms. Let's say a company wants to import goods from another country. In the traditional process, there are many documents and intermediaries involved, which can be time-consuming and prone to errors. By using blockchain technology, all relevant parties can have access to the same information in real time, eliminating the need for manual reconciliation. This transparent and secure system allows for faster and more efficient trade financing. It reduces the risk of fraud and enables better visibility into the entire supply chain, from the origin of goods to their final destination. These examples demonstrate how blockchain technology can revolutionize sectors like cross-border payments and trade finance. It brings transparency, efficiency, and security to these industries, ultimately benefiting businesses and individuals alike.
Thank you for providing those examples. It's fascinating to see how blockchain technology can streamline processes, increase transparency, and reduce costs in sectors like cross-border payments and trade finance. With these potential benefits, it's no wonder that blockchain has gained significant attention. Just to summarize, blockchain technology is a distributed ledger technology that securely links blocks of accounts together using cryptography. It offers features such as immutability and decentralization and can be implemented in different types of blockchains, including private, public, permissioned, and sidechains. The consensus mechanisms of proof of work and proof of stake ensure the validation and security of transactions within the blockchain. The significance lies in its ability to provide clear and safe data, enable fast business deals, resist errors, and be cost-effective. Blockchain can revolutionize sectors such as cross-border payments and trade finance by providing transparent and secure transactions, reducing intermediaries, and increasing efficiency. Thank you for sharing your expertise on this topic.